The next thing all students moving from class 10 to class 11th should be familiar with is units and dimensions. Well, dimensions might be something that you are hearing for the first time, but units you all are pretty comfortable with. You know, how do we measure quantities? Okay, we have standard units and non-standard units. For example, for length, we can measure length in meters, we can measure length in kilometers, we can measure length in yards, we can measure length in finger span, hand span, and so on. Now, some of these units are standard units, whereas some are non-standard units. The units that stay the same everywhere. For example, 1 meter, whatever is the length of 1 meter, will be the same in India, in United Kingdom, in Germany, in France. But the hand span will vary. A hand span in India, the average hand span will be different from the average hand span in some other country, right? So those or such measurements are non-standard measurements. Now, here we focus on only standard measurements. Within standard measurements also, we have different systems of measurement, different systems of units. So one system of units that you can see is written here. It's known as the SI system of units. This is the SI system. In SI system, length is always measured in meters, time is measured in seconds, mass or weight, mass is measured in kilograms, and so on. You can see what are the units in the SI system. Now, then we have something called the CGS system. CGS system. In CGS system, length is measured in centimeters, mass is measured in grams, time is measured in seconds, and so on. Okay, so, and there are other systems of unit besides these two. So there is something called the MKS system. MKS system was the original system on which the SI system was built. Okay, so you'll learn about these different systems of units. Here in this session, we focus on the SI system, the standard international system of units. You know that length can be measured in this unit. Meters is one of the units of length. It is actually the SI unit of length. Okay, so remember that. Similarly, remember the SI units of all these 7 quantities. These 7 quantities are called fundamental or base quantities. Okay, why fundamental and why not derived? All those things you are going to learn later. Okay, for now, just consider this as 7 chosen quantities. Okay, so there's a history about this. A bunch of people came together in France, they sat and they decided on a system of units. There itself, they decided that, okay, we are going to need some building blocks to different physical quantities. These are those building blocks, okay, which was decided by that group of people. So 7 fundamental units, okay, just randomly chosen. Of course, there was some logic behind choosing these as the fundamental units that you will see later when you study units and dimensions. For now, remember the 7 fundamental units: length, mass, time, temperature, luminous intensity, amount of substance, and electric current. Now that we are done with the recap, let's look at some new things that are introduced in class 11. Something called symbols of dimensions. Each of these physical quantities like force, length, mass, momentum, whatever physical quantities that you are going to read or you're going to study in classes 11th and 12th, you would be required to represent it using these symbols. Okay, so it's important to remember these symbols also. The symbol for length is L, symbol for time is T, mass M, and so on. Okay, now just to give you a quick example, See, let's talk about velocity. Okay, velocity is also a quantity, right? It's also a measurable physical quantity. But do you see that in the list of 7 fundamental quantities? I don't see it, right? So what is velocity then? It is a derived quantity. A derived quantity is a quantity, or is a physical quantity which can be represented in terms of fundamental quantities. Okay. So let's try to represent velocity using these symbols. So for that, we need to know what is the SI unit of velocity. See, velocity is given by distance upon time, right? To find the SI unit of velocity, we need to know what is the SI unit of distance. Distance is basically length, and the SI unit is meters. Upon time is measured in seconds, so we'll write seconds here. So we know velocity's unit is meter per second, right? If you have to represent velocity, the quantity velocity, using these symbols, we call that the dimensional formula of velocity. You will learn about that later. So if I have to write the dimensional formula of velocity, it's going to be meter, which is length. What is the symbol of length? Symbol of length is L. You can see. What is the symbol of time? See, this is in the denominator, so time to the power -1. Okay, this is one way to represent physical quantity. Actually, this is called the dimensional formula of velocity, Lt-1. We are going to use this, and this is a very helpful concept. You will see when you go into class 11th, the first chapter that you would be taught would be dimensional analysis. Okay, this has many usages that we'll see later. Okay, so a quick recap. Physical quantities, fundamental physical quantities, their SI units and their symbols. These symbols would be used to represent or to write the dimensional formula of different physical quantities. If I have to write the dimensional formula of, let's say, amount of substance, it would be simply this. Dimensional formula of amount of substance would be this. For luminous intensity, it's going to be J, enclosed within square brackets. Very important. You have to keep it within square brackets. Okay. So this is something that is going to help you when you go into class 11. Let's move on to the next concept.